Hi, I am doing the Check Your Understanding in Lesson 9-2 that's right in the middle of the lesson. It's on page 113. We didn't have time when we did our giant dry erase boards and we answered number 1, and we just didn't have time to do that Check Your Understanding. It took a long time to do that group work. So I've gone ahead and recreated the Pebble Pattern A and Pebble Pattern B that are written on that page. And then we're going to go ahead and answer. Number 3 says, what is the constant difference for each of the pebble pattern shown on the tables? So I'm looking here and I'm going from 3 to 7 is 4, from 7 to 11 is 4, from 11 to 15. So for pebble, I'm going to call it PP, pebble pattern A, the constant difference is 4. Okay, for the pebble pattern B, the constant difference, let's see, this is 5. It looks like constant difference is 5. All I'm doing is subtracting the constant terms. Oh, and I have an announcement.
Attention students in the building, if you are not with a teacher or a coach, you need to leave the building at this time. If you are supposed to be here for the movie, return to the auxiliary gym immediately. There should be no students in the hallway.
Okay, so we know this is October 21st, Back to the Future Day, and everyone's supposed to be in the movie. Okay, so number 4. For each pebble pattern, use the variable n to write an expression for the nth figure. So when I'm looking at the first one, if I have a constant difference of 4, that's where I'm going to start. 4n, and then I have to make an adjustment. So if I go from 1 to 3 and make that adjustment, 4 times 1 is 4. I need to subtract off 1 to give me the 3. And see if it works for if I put it in here. 4 times 2 is 8, subtract 1 is 7. 3 times 4 is 12, subtract 1 is 11. Okay, so that ends up working for my first pattern. My second pattern, I'm going to use my constant difference is 5, and then see if that works. 5 times 1 is 5. That means I need to subtract off 3 to get to here. Okay, so I'm always looking at the first one and then seeing if it works. So if I put in figure number 2, 5 times 2, right here, 5 times 2 is 10, subtract 3 is 7. It works. Okay, and I promise it works all the way down. Okay, so that's my A and B here. Pebble pattern A, pebble pattern B. So now I'm on number 5, which says how many pebbles are in the 50th figure for each pebble pattern. So this is when I'm going to look and I'm going to put 50 in for the figure on both of these. And then I can use my calculator if I need to. But 4 times 50, you should know that, hopefully, is 200. And then if I subtract off 1, that gives me 199 pebbles. And if I do likewise, 5 times 50 minus 3, that's going to give me 247 pebbles. Again, you could use your calculator here. It's just PEMDAS. Let me scoot this up. Sorry, guys. So all I did was put in 50 for n in my expression because I'm talking about the figure. I want to know, excuse me, find out who's watching my videos because they're going to say, there was an announcement and you sneezed. Okay, so I found the pebbles for 50, for figure 50 in both of these patterns. The last question on the Check Your Understanding says both pebble patterns have 7 pebbles in figure 2. So if I circle those so that you can see here, both of them have 7 pebbles in the second picture. If the patterns continue, will they ever have the same number of pebbles as another figure later on in the pattern? And then it says explain. So I'm just going to verbally tell you this one here, so instead of writing this all out. But the answer is no. I can write no. And the reason is pattern B keeps getting bigger and bigger by 5 in each figure, while pattern A only gets bigger by 4 in each figure. So pattern B is always, always, always going to have more pebbles than pattern A for the rest of their pattern. So it just kind of lucked out that they had the same number for the second picture, but here on out, the second pattern here is always going to have more. It's never going to be the same. Okay, so I will see you in class, and I'm going to do the second Check Your Understanding in a different video. All right, thanks.